In this video, I want to introduce polynomials to you, if you haven't already seen them. Polynomials are very common in algebra class, so there's a good chance that you've already seen them before, and sometimes they can be a little abstract of what they even are. But if you're in the club and you already know what they are, then you'd recognize this as something we would call a polynomial, x squared plus 3x plus 2. So all of this is considered a polynomial, okay? Now, the definition in the book, or the definition in mathematics textbooks, can be a little abstract. And these a's here are just numbers. They're coefficients, okay? Now, for something like this, we would understand that this number right here, which doesn't look like a number at all, it's like black, is actually the number 1. And we don't write the number 1 every time it appears. We just understand that if there's nothing there, then it's a 1, okay? So, so we would say that the leading coefficient, and we're going to get into those words in a minute, would be 1 for this. The coefficient for this is 3, and this is the middle term, and the last one is 2. Now notice the 2 doesn't have an x at all, and that's very common. And I've written these in like descending order, so this is considered the largest, this is considered the smallest, even though this is a 1 and a 2. But they won't always be in order, but it's better if they are, because we can more clearly understand just by looking at them. Okay, so let's keep going. So the next thing I want to introduce is what is a monomial, what is a binomial, what is a trinomial, and going on, we'll just say what is a polynomial, okay? Now, a monomial is something that can be written as 1. So mono is meaning 1. Now, monomial, just 1, that could just be the number 5. The number 5 could be thought of as a monomial, but also 5x. 5x could be considered a monomial. Since these are multiplied, we consider this one term. 5x squared can be, just by itself, could be considered a monomial, okay? And something really complicated, 5x squared y. Even though this has 3 things, this is considered a monomial because they're attached through multiplication. Now, a binomial, bi meaning 2, means like bicycle, is going to be something that has 2 terms, okay? So something like 5 plus x would be considered a binomial. 5x plus 3 is a binomial. Notice there's a lot of things here. There's a 5, an x, and a 3, but this is considered a binomial because it has 2 terms. How about 5x squared minus 7? This is also a binomial because it has 2 terms separated by subtraction. Let's say we have 5x squared y plus 3. This is also a binomial. Okay, it has 2 terms. So the separation of addition is what's going to make, or subtraction, is what's going to make the counting of the terms. Now the trinomial, tri meaning 3, like triangle, means it has 3 terms. And we looked at that at the first slide. So something like 3x plus 2. This is considered a trinomial. We're almost always going to look at binomials and trinomials. Now, of course, you can have polynomials, just meaning that it's greater than 1. So actually, anything other than a monomial would be a polynomial, because poly just means many. Sometimes I'll refer to trinomials as trinomials, but more often I will say monomial, binomial, polynomial, okay? I'm not going to test you on the language. I just want you to understand the language that I'm using. So again, we might have x cubed plus 2x plus 3, okay? That's still a trinomial, even though this has a higher order, okay? Let's keep going. So the leading coefficient, the number of the highest terms, okay, this is a vocab term, and sometimes we have to understand what the leading coefficient. So let me go back to actually I have an example right here. So a leading coefficient is this number 2 right here. This is the leading coefficient, all right? The leading term is the term with the highest degree. Highest degree is indicated by the exponents. This is a 2. So the leading term, this is the leading term. This is the leading term, okay? So the leading coefficient is 2, and the leading term is 2x squared, okay? I'm not going to test you on these vocabulary words. I'm just trying to explain when I use them, what I'm talking about. Okay, now let's talk about degrees, and we'll talk about how you can determine the degree of, say, a trinomial like these, okay? Now, the degree is the highest power of the highest term, okay? So what's the highest power? Well, the powers I have are 3, 2, and then technically this is 0 because there's no x here. So the highest power here would be 3, so that's 3. So the degree of this trinomial is 3, okay? Now, for this next one, very similar. I have 5, 3, and 1 to choose from. Well, the highest one is 5. So the degree of this trinomial is 5, okay? Now, for this next one, it's a little bit more complicated because this leading term here has 2 and 2. This is 1 and 1, and this is 1, okay? So actually, the degree of this is that you add them. So you add those. So the 2 plus 2 equals 4. I just want to indicate that I'm adding them and not multiplying them because coincidentally they would be the same number. So I'm adding those to get 4. Okay, and that only happens if you have this double variable. Okay, let's do one more example just to make sure that that's clear. X to the third times say y plus 2xy plus 4. So for this, the degree would equal 3 plus 1. So this is also 4, but for a different reason. 3 plus 1 is 4. And this would be 2. 1 plus 1 is 2. And then this would be 0. So the degree of the polynomial here is 4. Adding and subtracting polynomials is the next thing in this section. It's very easy to do, but the thing that's most commonly missed is students will they'll accidentally multiply and make the problem a lot harder because of the parentheses. They see the parentheses and they start multiplying and they get it wrong. So for these, let's keep it simple because it's a simple problem. We're going to subtract these two binomials, okay? Now, I can only combine like terms. So I have an x squared term here and an x squared term here. So I can those two only manipulate. Again, we're subtracting and we're not adding or multiplying, okay? So I have 12x squared minus 8x squared. Well, that would be a difference of 4x squared, okay? Now, apologies, I'm getting a phone call. The next thing would be to worry about the x's. So I have 3x minus, there's no x term here. So I can't do anything with it. So I just bring it down, 3x. Okay. Then I have no numeral here, minus negative 19. And the negative is going to make that positive. Okay. So this would be my final answer of that subtraction problem. All right. So hopefully that helps you. Let's look at this one. 6w squared plus 24w plus 24 minus 3w squared minus 6w plus 3. Again, I'm subtracting here. I'm not adding or multiplying. So let's be careful. 6w squared minus 3w squared would be a difference of 3w squared. 24w minus 6w is going to make it 24 plus 6w, okay? And that's going to be 30w. All right, next, 24 minus 3 makes 21. Okay, so that would be my final answer. All right. Next, Similar problem, 11b to the fourth minus 6b cubed plus 18b squared minus 4b plus 8 minus the group 3b cubed plus 6b squared plus 3b. Let's see if we can do this. I can only combine like terms. So first I have 11b to the fourth, so I can only combine 11 to b to the fourth. There isn't another one, so I will just bring that down. Okay, let's look at the b cubes. Negative 6b cubed minus 3b cubed. Okay, well that's going to be minus 9b cubed. Okay. 18b squared minus 6b, minus 6b squared. So that's going to be positive 12b squared minus 4b minus 3b. So that would be negative 7b. 8 minus, oh, there isn't a numeral, so I'll just bring that out. And that would be my final answer. Okay. Now I focused on subtraction because that's probably the more complicated, but addition, you just add them. Okay. So hopefully that helps. Let me know if you have any further questions about adding them. Next video will be about multiplying.